Example 2, we have function fx equals to 2 plus log to the base 1 over 3 x minus 4. So in this case here, for the first step, we find out that the base number doesn't fulfill the requirement of our step 1, where we want the base number here greater than 1, but in this case here, we have the case of 1 over 3. So what we're going to do now is that we're going to change it into a base number which is greater than 1, and from here, the idea is that the ideal base number that we want to use is just that we consider this base number here originally 1 over 3. We overturn the numerator and denominator to become 3 over 1. So therefore, we would like to use base 3 in this case here. So by using our knowledge on changing base on log, we change it into base 3, and we have the result as follows: 2 minus log to the base 3 x minus 4. So we are going to use this one as a reference for the graph sketching later. And if let's say we want to compare in details on this new form here with our general equation, this is what we happen to find out, where we have our a, which is the coefficient of log, is -1. The m, the coefficient of x, is 1. The c, which is the constant within the brackets here, -4. And then the k, the constant outside, is 2. And one thing is missed out here, the small letter a, which is the base number, which is equals to 3 now, in this case here, after we make changes. Next, step 2, we would like to see the shape of the graph. And how we determine the shape of the graph, again, we're going to observe on two parts there. First, the coefficient of x. In here, we have positive coefficient of x. For the coefficient of log, the coefficient of the functions, we will have the case of we have negative log. For the case the base number is greater than 1. Again, we don't refer to this original one which the base is less than 1, but refer to this one after we change the base. So in this case here, we have negative for log, positive for x, and to determine the shape, we begin with the basic case where we have positive x and positive function on log, where the base is greater than 1. The shape will look something like this. Then, now, in order to achieve the answer we want for this function here, we will see that the changes is made on the log function. From plus, we want to change to minus. So, from plus log, when the time we want to change to minus log, what will happen is that we will have the graph flip vertically. When the time we want to have plus log become negative log, so we will have it flip vertically, and as a result, this is how the shape looks like for the graph that we want. Then after here, what we're going to do the next is that we're going to determine what is the important line in this case here, where the important line refers to the vertical asymptote. Step 3, for the special line in this case here is the vertical asymptote, and the way we get the answer for the vertical asymptote is that we take the bracket term here, x minus 4 here, we make it equal to 0, and we have the answer x equals to 4, and therefore this is what we have for the vertical asymptote. And as a result, with all this information here from step 1 until step 3, we shall able to proceed to step 4 to determine the x and y intercept. But before this, once again, up to step 3 here, we just like to roughly go through by using a simple graphical methods to determine the domain and range for this function here in general. So by the time this graph is being extended again, if we want to refer to the case of domain, we want to see how far to the left and how far to the right the graph can go. We notice that the graph can go to the left as far as somewhere very close to 4 but never reach 4, so we have open bracket 4, and to the right it will go all the way until infinity. Whereas for the range, we can see it can extend upwards and downward infinitely, so therefore I have infinity to infinity. Now this is the domain and range for this function here in general. Next, step 4, we would like to find out the x and y intercept, but before this, let us try to observe from the rough sketch here whether do they exist in our graph or not. So, with the help of the special line, which is the asymptote, we have x equals to 4. With the shape of the graph that we find out just now, we find out that in this case here, we're going to have a x-intercept only. There is no y-intercept in this case here, so we shall not waste time to find out the y-intercept, but we just focus on the calculation on the x-intercept. So y-intercept does not exist, and we proceed with x-intercept by letting the function equal to 0, and we solve using calculator. I suppose I have the answer x equals to 13, where the x-intercept now is equals to 13, and go on with the x-intercept with the asymptote and also the shape of the graph that we have. There goes the answer that we shall have for the graph of function fx equals to 2 plus log to the base 1 over 3 x minus 4. And remember, always label the xy axis, label the origin, label the name of the graph, which is the name of the functions, label the xy intercept if they exist, and also the special line, vertical asymptote. And this is how we get the answer for example 2 for log functions.